Okay, we're going to help you through a little practice. First one here is combinations of functions. So I have this function. Let's get the markup going here. This function here is 3x plus 4, and this function here, 4x squared plus 5x. To add them together, f plus g, we put f, and we'll do our work over here and then put our answer here. So our f, 3x plus 4, added to g, plus, and then we just put g, 4x squared plus 5x. Now we like to use the highest powers first when we add up our polynomial, put it back together. And there are only 4x squareds. We can't add that to the 3x because that's only an x with no exponent. So we have 4x squared. And then we have 3x there and 5x there. Get added together. They are separate from 4x squared. So 3x plus 5x gives us 8x. And then our constants, we just have the 4 by itself. Plus 4. There is our answer. This is f, and this is g. Alright, let's do the same thing with this one. 2x plus 2 is our f. 5x squared plus 5x is our g. Alright, let's come over here. F, 2x plus 2. That's f. G. And we're doing the plus. Plus. And then the g is 5x squared plus 5x. Don't worry about simplifying that, factoring out anything. All we're doing is finding the polynomial. Okay, there's only 5x squareds around. So, we start with the highest degree, 5x squared, and what else do we have? We have 2x's over here, and another 5x over here, so it'll be plus 7x. And we just have the one constant, plus 2. Adding f plus g. Now coming further down here, and I'm going to do it another way. I'm going to establish a table here. We're looking for the value at 1, -2, -5, and 5. Let's just put those values here and make a table. And we'll have the x value of 1, -2, -5, and 5. And then let's calculate f of x. Alright. 1 squared plus 7 times 1 plus 6 equals 14. F of -2 gives you -2 squared, 4, minus 14, 7 times 2, plus 6, or minus 10 plus 6 minus 4. -5. F of -5 would be 25 minus 35 minus 7 times 5 plus 6. 25 minus 35 is -10 plus 6. Oh, another -4. And last one, f of 5 would be 25 plus 35 plus 6. 25 plus 35 gives us 50 plus 10 gives us 60 plus 6 equals 66. Let's do the same thing for g of x. Alright, they're a little easier because we're just adding 6 to it. So 6 plus 1, 7. Negative 2 plus 6, 4. Negative 5 plus 6, 1. And 5 plus 6, 11. Now that we have these tables, it's going to be a lot easier to do. F plus g at 1 would be 14 plus 7, 21. F minus g at negative 2, negative 4 minus 4, negative 8. F times g at negative 5, negative 4 times 1, negative 4. And f divided by g, they gave us some convenient numbers. 66 divided by 11 gives us 6. So when they're asking for specific values, much of the time it's easier just to put in the x. Sometimes if you're given a lot of x's, it may be more convenient to calculate it out just using the value x. But usually, if they're only giving you a few values of x, it's easier just to build this table. Because sometimes there's a lot of algebra involved in this. I know I could see what, if I want to factor this out, I see this as x plus 6 times x plus 1. I guess that helps me when I do the f over g. I know that f over g is x plus 6 divided by, times x plus 1 divided by x plus 6. So I know that this is going to be x plus 1. But I don't have to do that. I know their values at 5. But if I wanted the general form, I'd have to remember properly I cannot divide by 0, so I'd have to say x is not equal to negative 6 because f over g would be dividing by 0. But otherwise, the general form is that's equal to x plus 1. But that's the only time that the doing the polynomial really is useful. Multiplying out, that gets a lot more complicated. But you could do the multiply. Otherwise, the plus and minus is basic algebra, or basic addition of the functions. Let's do that same table here for this one. We have different x values. Oh, sorry. We're finding the general form. Okay. We don't know what x is. We're saying for any x. Well, let's add them together. And I'll do the work over here and come back and put my answer. So the work over here, when you do f plus g of x, it's the same as just adding the two functions together. So let's take f, x squared minus 12x plus 35. Add the g of x plus x minus 7. Well, there are no more x squareds than what I already had in f. So I know that there's 1x squared. How many x's are there? There's minus 12 and there's plus 1. So it becomes a minus 11x. And there's a plus 35 and a minus 7. So that becomes a plus 28. F minus g, x squared minus 12x plus 35 minus, and let's be careful with signs here, x minus 7. That becomes minus x plus 7 if I pull it out of the parentheses. Now let's find the result. I still have just one x squared laying around. I have a minus 12x and a minus another x, so minus 13x. It's a plus 35 and a plus 7 plus 42. Now the times, that's the most difficult one. Let's do that carefully. It's going to be x minus 7 times, and the order doesn't matter. Let's go ahead and put it in the exact order they give us. I'm going to make sure I have enough room here. X squared minus 12x plus 35. The quantity times g, x minus 7. So let's do our multiplies by x and then subtract the multiplies by 7. So x times all of this minus 7 times all of this. So let's do x times all of that. X times x squared, x cubed, minus 12x squared plus 35x. Okay, there's x times all of that. So that would be x times f of x. These are what we have right here. And we're subtracting 7 times all of that. So I'm subtracting 7x squared. I'm subtracting 7 times negative 12x. So it would be plus 7 times 10 plus 7 times 2, 84x. And subtracting 7 times 35. Well, 7 times 30 is 210. 7 times 5 is 35. So it's minus 245. Now, let's combine the two. So this part here is the minus 7 times f of x. That's what all that becomes. Now we put all our highest powers together. There's only one x cubed, so we have an x cubed. And then we have minus 12x squared minus 7x squared. That becomes minus 19x squared. So we're done with those. We have a 35x and an 84x. 80 plus 30 is 110. 4 plus 5 is 9. So 119x. And minus 245 is the only thing I have left over. That's the hardest part of that problem. Now, this one, I'm going to simplify because I think factoring here might help me. And let's just try that. Factoring this, it looks like I can make that, I can see that that is x minus 7 times x minus 5. Seven times 5 gives me plus 35, minus a 7 and minus a number of 5 gives me 12. Doing that then, and doing f divided by g, I get, I'll just put the work over here, x minus 7 times x minus 5 divided by x minus 7. Well, x minus 7 is canceled out, except for where x is equal to 7, so I have to stipulate this isn't valid when x is equal to 7. So, but in general, the solution is x minus 5. F divided by g of x. Now in the solution, they just show you this as valid. I like to add in parentheses x is not equal to 7 because we're not allowed to divide by 0. It does approach this as I get closer and closer to x equal to 7. But that's a detail. This is all you have to put for the answer. You're allowed to divide out that x minus 5. because this is good practice, this is probably the hardest part of all this. Let's do one more. And I don't want this video to go too long. Oh, I'm going to stop here. Then we'll stop here and do this on the next video because I don't want to make these more than about 15 minutes.